Okay, I think we might get started today. So, welcome to CPR, the Center for Policy Research. For those of you who haven't met yet, my name is Navroz Dubash. I'm a senior fellow here, um, and we are today very happy to be inaugurating a new seminar series, which we've called "Clearing the Air," but with a question mark. So we thought a little bit about what to call this. You know, Indian Express has come up with its much more punchy, but also perhaps slightly more pessimistic "Death by Breath." We thought we'd be a little bit more upbeat, but clearly the air is on our collective mind. It's also on the mind of our Sri Lankan friends, as we found out over the weekend. There's a lot of discussion and debate about this. Now, I should just make clear that we at CPR don't actually haven't in the past worked directly on air quality issues. We worked on many issues that are related to it. We work on energy, we work on environmental institutions, we work on climate change, but we haven't worked on the technical and policy aspects directly of air. But like many others, we are very distraught about the condition of the city's air, of the region's air, and we thought that we would actually get together. This series really comes out of an effort within CPR to get together and think about how we might educate ourselves with a view to actually getting more involved in the debate, but also making it easier for others to get involved in the debate. So we decided to start by doing what we know how to do best, which is gather information through a seminar series. What we're planning to do, this is very, very early days, but what we're planning to do is actually build a little bit of a resource, a database of information, actors, institutions, but also articles that map each of the topics that we'll cover and make that publicly accessible, so that people who want to get involved have an easier entry point to getting involved. And then we'll sort of take stock after a few months and see where we are. But you can now expect, if you're on our mailing list, getting a regular series of announcements. This is the first one. We're hoping that this will in fact be regular, it will be systematic, and we're hoping to add some value by curating the information in some way. So please, we're really glad that you took the time to come today, and please stay on your email and show up to future events. We're going to aim for a frequency of about every 2 weeks, but that will be interrupted by things like this December break and so on. So that's why we're doing this, and we're hoping to just both stimulate a broader conversation and be part of that conversation. We're really, really very happy that the first such seminar we get a chance to host Dr. Sarath Gutikunda, who's a friend of ours. We've interacted over the years on air and energy issues, and Sharath is really kind of a unique individual in this landscape. It's always strikes me as kind of amazing that in a country this size and scale, we don't have more people doing the kind of work that Sharath has pioneered, but we're really glad that Sharath is doing it. Sharath is the founder and director of urbanimissions.info. Sharath has lots of accolades, as you might expect. He's a NASA Earth and Space Science Fellow. He's a TED Fellow. And his work really is at this intersection of air quality analysis at urban, regional, and global scales, thinking about both the science, policy, and public dialogue around air. He's the developer and practitioner of lots of tools that help us have these conversations, and he's going to talk us through some of the information that he has available in order to inform this question about how much do we know about Delhi's and the region's pollution load, and is that information adequate to start having a policy conversation? How do we start moving, how do we both identify data gaps and start moving to policy? So Sharath is going to talk us through his material for about 35-40 minutes. We can interrupt him, if you don't mind, only if there's some pressing question of clarification, and then we'll have a chance to pepper him with more questions in the question and answer session. So with that, over to you, Sharath, and we look forward to the presentation and the discussion.
Thank you. Hi. Good evening. So I'll continue from there, and just to give you a quick background on what air pollutants that we are talking about, because we get a very common question, and why are we always focusing on PM 2.5? If we look at a lot of news articles, there's always question, like, why are we not talking about SO2, NOx, VOCs, and all those things as well? So we are interested in all the pollutants. All the pollutants are linked to our health impacts. It just happens that PM 2.5 is linked to our health impacts a lot more, and it just so happens that every one of those gaseous species, SO2, NO2, ozone, CO, VOC, in some form or the other, at some point in time, they end up in PM 2.5. Okay, so SO2 becomes sulfate aerosols, it's part of PM 2.5. NOx, VOC, CO, and ozone, they interact between themselves, they end up forming nitrate aerosols and secondary organic aerosols, and they all part of PM 2.5. So if we are talking about PM 2.5 as a whole, we are actually talking about all of them. Okay, if we are targeting PM 2.5 as our primary indicator in our policy realm, we are targeting all the other pollutants as well. So it's very important that you actually measure all the pollutants, but it's okay to talk about just PM 2.5 and drive a policy conversation on it. So I'm going to talk about PM 2.5. And health impacts, there's a lot and lot of literature coming out, a lot of epidemiological studies are being conducted across the world. Very few are being done in India, but evidence is there, and a lot of these linkages should be taken very seriously, and hopefully more and more of those works will happen in India as well. I think we'll have one or two speakers in the coming months who will talk more about that. And this is an article that we wrote in The Wire in September, saying, when do we talk about air pollution? And that arrow point, that last week actually refers to the last week of September, saying in a couple of weeks, we're all going to talk about air pollution. And because till then, nothing happens. And most often, that's get triggered when Diwali comes into picture, just like in 2016 and just like in 2015. And this is a new data feed that comes from Google. You can actually put in a search term and see how the interest has been on that topic. So, topic on Delhi's air quality, the interest is at 100% in 2016. Sorry, wrong numbers. That should have been 2017 and 2017. I made them this morning. So in 2017, the interest was really at the peak, so it's 100%. And in 2016's interest, that's Diwali peak, that was around 50%. And then compared to 2017's peak interest, 2015's interest was almost negligible. Okay, but in 2015, peak was there. In 2016, peak was there, and now today peak is there. So it's actually a positive trend in the sense more and more people are interested in the topic. Public is interested in the topic. They're searching for it. They're looking for more information on this topic, and I think that is what is driving the conversation. And it just so happens that I also get invited more to talk about air pollution when this peak happens. In between months, April, May, June, July, nobody really calls because nobody really cares at that point. And staying on the Diwali topic, was 2016 or 2017? Was 2017 better because some law was passed and there was a stamp on a piece of paper? Not really. If you look at the peaks that happened in 2016 versus 2017, they're the same. The median levels were the same. If anything, 2016's meteorology was worse during Diwali than 2017. It only means, in mathematical terms, that if anything, there were more firecrackers burnt in 2017 than 2016. It's not easy to prove it, but we're trying to understand that. So just for 2017, the meteorology was really, really favorable in the sense within 2 days, all those peaks were all gone. We were back to the normal of what we were seeing in those 15 days before Diwali. Okay, so it doesn't mean that that number is actually lower. That average was around 160 micrograms per meter cube. That's 6 times worse than WHO guideline and 4 times worse than our national guideline itself. Okay, so it is very evident this time. Last time, the evidence of crackers was a little bit muddled between the peak of the forest fires, the open fires that happened, but this time it was very, very clear. So we know that good chunk of that firecrackers actually happened. And this is the only year also we know how much firecrackers were burnt in Delhi. And thanks to, again, because of that law that was passed to ban the sales, the distributors and sellers, they filed a countersuit. And in that paper, they actually said we have 5 million kilos of firecrackers for sale in NCR, and this is 30% of the national stock. This is the only time. How much was it in 2016? We don't know. 2015? We don't know. So this is the only. So one positive thing is we know how much actually gets burnt in NCR, and that's 30% of the national stock. So I want you to keep that in mind. So 2% of the population, less than 0.2% of the national land area, is burning 30% of the firecrackers in 2 days. Okay. I don't know whether you want to be proud of it or not. So again, we get a lot of these questions. Did public comply? I mean, if public actually complied to that law, and actually people said, okay, we're not going to buy and we're not going to burn, that's where you would be at the dotted line. But we weren't. No, we actually matched the numbers only when we burned that 5 million kilos of firecrackers in that NCR box. Okay. Generally, we always want to blame the weather. Okay. So we want to blame winter weather for all our problems. Okay. It's a very common thing. So I wanted to put a mathematical twist to it so that we are all on the same page. So concentration, ambient pollution that we are always breathing, that's what we are interested in. We are not interested in the emission loads. We are not interested in how much are the emissions at the stack or in the car or the stove. We are interested in how much is actually staying in the air, because that's what we are breathing. Okay. So if you consider your city as a box and you have a volume, you have your length, width, and the height. That height is basically defined by the inversion. So everybody has an idea of inversion is very strong in the winter time, so things get compressed. So that's basically your volume. If your mass is your emissions is constant, and your concentration is by mass over volume. So what happens in the winter time? That volume goes down. And if your mass remains the same, your pollution is going to go up. But what happens is your mass also goes up in the winter time. Okay, so combination of all these things. This Diwali, emissions are going up, your open fires are going up, temperatures are dropping, so there's a lot of space heating happening. Okay, people are using waste, wood, coal, anything they can get their hands on. So winter time, your mass also goes up and the volume comes down, and your total pollution is much higher than usual. Okay. Again, it's coming back to the peak story. So this is where we are right now. So last week, are we better off? And the interest in the topic literally is like a 10% of what it was a few weeks ago. So November 6th and 7th, it was 100%. We are like back to almost like 10% of that. So are we really like clear of the pollution levels? No. I mean, we saw all the Sri Lankan players putting on masks and vomiting on the court, on the field. So it's not. So just look at the last 45 days. Okay. So we had the two peaks, the Diwali peak, and then we had the open fires, very baffling meteorology in those 3 days. And we had those peaks, but the running mean for the last 45 days is at 180 micrograms per meter cube. And it's not a laughing stock. So today's average, so that box, we don't have the today's numbers there. Today's average of the last from midnight to 3 p.m. is 320 micrograms per meter cube. Okay, so we are always comparing ourselves to those 800s and 900s micrograms per meter cube. We are like, "Hare, this is nothing. No, I survived 800." No? So that's the mentality we are in. And it really is a downing situation.
Sorry, can you show us where the 320 comes from? It doesn't look like it on the top.
Yeah, today's number. This is for till yesterday. So this is not in. And I made this only yesterday and just for December 4th, December 3rd. And So if we look at July, August, the only difference between then and now are rains. Okay? The emission loads are actually the same. And this is the only reason why we drop our averages to what we see as annual averages. Okay, and I want you to focus on that. If we focus on the episodes only and start talking about only episodes, you don't have a long-term vision. Okay.
The range means what's in the air comes on the ground.
Sorry.
Range means what's in the air.
Range.
When rains happen.
Rain, yes.
What's in the air essentially comes on the ground.
Yes. A lot of wet scavenging happens.
So that's why the air becomes
cleaner. Yeah. So this is the average of all the stations that we have here. So annual average is 150 micrograms per meter cube. Okay, including all those peaks and everything else. Okay, that's 15 times more than WHO guideline and 4 times worse than our national guideline. So if we only talk about air pollution when it peaks to 800 or 900 and rest of the year nothing, we don't have a long-term vision. Okay. So it's really important that we change that, and I think there are a lot of conversations that are happening at least this year are trying to look at that long-term vision. Okay. So this is the story that comes from the monitoring stations. So all the graphs that I showed you, box plots and everything else, all that information comes from the monitoring stations only. Okay. So that number is telling you today we are exposed to 300 micrograms per meter cube. It doesn't tell you any other information. Okay. So at the end of the day, when we want to have a policy conversations and we want to have more deeper understanding of where is that pollution coming from, what we need to do to reduce that number. So this is where a lot of conversation has to go in, and this is where we also step in and do a lot of our work. And a lot of the science and understanding, this is where is missing. So we end up talking about that peak of Diwali, and it's very clear, it's there. So it's like, see, all the pollution that is coming from firecrackers. But that's only 2 days, and then you have 363 days behind it. Again, open fires is the same case. When you have those big highs for 7 days, maybe 10 days, and then you're back to these 200s and 300s, and we are not even talking about it. So we need to break that up. So we're trying to understand this pie that will drive the conversation more in not only in Delhi but a lot of other places as well. Okay. Now this is where the science comes in, and a lot of misunderstandings are also there. Okay. And because some stories get written up in newspapers, everybody reads those. Everybody looks at one pie that's published in the articles or in the news, in the NDTV news and things like that. But nobody goes back and reads the actual report. How did that pie come up? So I have a little background note on this, and there is also a little, all this is illustrated here as well. So I want you to understand these approaches a little bit, so that when we have this conversation on how do we know how much pollution is coming from what source, so you have a better understanding of this. So we have two approaches. One we have called a top-down approach, and one is a bottom-up approach. So top-down is more a monitoring-based approach. So where you're actually collecting samples at certain locations, okay, and how many samples do you collect and where you collect is very, very important. If you collect that sample next to a road and you selected 4 of those stations, you are skewed to have an analysis which says transport is your biggest problem. Okay, and for a place like Delhi, if you just do 4 points, you are skewed to have a statistically insignificant pie, and that's what happens in the past works as well. And then you have to take them to the lab and do a chemical analysis, proper chemical analysis. There are a lot of steps involved. You want to find out ions, what kind of metals, how much carbon is there, like organic carbon, elemental carbon, secondary carbon. So a lot of things have to go in. It's expensive exercise that has to be done properly. So in India, there are only 1 or 2 labs. Like certified lab is only one, NEERI, in Nagpur, and they have a waiting period of at least a year or 2 years if you send samples to do chemical analysis. Okay, and they are as expensive as sending it to US or EU and getting it done over there and bringing it back. Okay, so we have so many studies that we want to do, but we don't have that laboratory analysis. So that's one of the reasons why a lot of work, a lot of groups from US and EU come in with their own sampler, collect samples, and they go back and do the analysis and they write papers, and we don't have anything locally being done at this level. Sorry? NEERI is CPCB. I mean, they are all part of the same pool. So within CPCB, they don't do this analysis. Everything goes to NEERI. So, and then, if anybody tells you that both the approaches, like one approach is primarily monitoring and then other one is primarily modeling, that's not true. Both the approaches are model based. At the end of the day, you are modeling in both the approaches. Okay, so this one we call it as receptor modeling. So what happens is you take a chemical sample at a ambient location, you do the chemical analysis, and it gives you a profile saying it has so much iron, so much metal, and things like that. And what we have is source profiles. Okay, so a coal will have a chemical signature in a certain way. Okay, a biomass burning will have a certain signature, and sea salt will have a certain signature. If you burn petrol, will have a certain signature. Diesel will have a certain signature. So what receptor modeling does is statistically matches. If this is the library of source profiles you have, this is the ambient profile we have measured, it statistically tries to match it and says that ambient profile will have contribution of 20% from coal, 10% from fuel, from petrol, diesel, biomass, sea salt, things like that, and it gives you a pie. Okay, and every one of these sources have a very distinct chemical signature that one can actually track. Okay, so there are pros and cons in this top-down approach. Okay, it's a very well tested. Pretty much every country does it. Only thing is very expensive in collecting. A lot of quality control has to go in. Chemical analysis is also very expensive. It's location and time specific. So when you collect that sample, where you collect that sample is very, very important. Okay, and then fuel differentiation is possible because every fuel has a chemical signature. Okay, that doesn't directly translate to source signature, meaning a chemical signature, you cannot differentiate between diesel burnt in a diesel generator versus diesel getting burnt in a truck. Okay, or coal that's getting burnt in an industry versus a power plant versus a stove. Coal is coal. It has a certain chemical signature. So fuel differentiation is possible. Source differentiation is something that you have to hand wave and come up with. Okay. And this also has garbage in, garbage out. And I'll give you a very quick example. So this is the source apportionment work done by CPCB in 2010, published in 2010 for multiple cities. And this is for Delhi. The first report that actually came out, actually for PM2.5, it said LPG combustion is responsible for 40% of your PM2.5 pollution. It's logically not possible. So what this means is the source profiles that were fed to do the statistical matching had some problem. Somehow it went through the reviews, peer reviews and everything, it got actually published. And there was a lot of halagulla, we raised a lot of noise. How is it logically possible? They removed that and only PM10 results were published. So everything is modeled. So you have to be very, very clean about that. Then you have the bottom-up approach. So here again, everything is modeled. So what happens here is, so you have to have a good understanding of all your emission sources in your urban airshed. So if you defined this is my urban airshed have a city of 60 by 60 kilometers or 40 by 40 kilometers, you basically try to understand all the sources that are contributing in that urban airshed. Okay, and you have good understanding of the meteorology. The meteorological models are all well defined. A lot of databases are online, free. All you need is a big server. And even 5 years ago, 10 years ago, that used to be a problem. But now, thanks to Google and Amazon, you can hire big servers, and that's what we do. We do all our calculations on Amazon. So, having said that, you combine everything, then you will have a good understanding of your emission loads. Combined with metrology, it will give you concentrations, and you break it up into, depending on how detailed your sources are, you will have the source contributions. So it's a total bottom-up understanding of that. So a lot of layers of information fed into this kind of approach, and we maintain. So this is our specialty. So we digitize a lot of maps, we digitize a lot of reports that are coming from different sectors, and we try to understand spatially, temporally, what are the emission loads in the country at a very, very fine level for the cities, and we try to build an understanding of the contributions. Even this has pros and cons. Concept is well tested. It's a variable expense. It entirely depends on how detailed your inventory is and how much you want to spend on your Amazon or Google servers to do as much detail as possible. Here, source and fuel differentiation is possible, okay, because it entirely depends on how detailed your inventory is. Okay, if your emissions inventory is fuel-based, then you will have a fuel-based source apportionment. If your inventory is actually at the sector level, then you have a sector-based source apportionment. So it entirely depends on that. Again, this also has garbage in, garbage out. So when we are most often borrowing emission factors from tests done from different countries. So, for example, you do tests in Pune and we're applying it to Delhi. I mean, there is some give and take. Ideally, we want to get all those tests done also in Delhi. So there is a lot of hand waving happens here as well.
What is an emission factor?
So emission factor is how much pollutant is coming out of a particular source. So you have, for transport sector, we often measure that in how many grams of PM2.5 is coming out per kilometer of vehicle traveled. For power plant, you have how many grams of PM2.5 is coming out per ton of coal or diesel burnt in the power plant. So ideally speaking, both these approaches should be talking to each other. So if you collected enough samples across your urban airshed, you did your QA/QC, you did your chemical analysis properly, so you will have a good chemically analyzed fuel-based apportionment of your samples. So you have that. So if you have a good understanding of your emissions load, both spatially and temporally, and you come up with a pie of that, both source and fuel, ideally they should be talking to each other. Okay, then you have a good understanding of what the source contributions are. Okay, so do we know enough from all the studies that were done in the past that we can take it forward, especially for Delhi at least? So this is a study published in 2007 based on samples collected in 2002-2003. Okay. So if you look at the averages, daily averages that they measured then, they're very similar to what we are measuring now. Okay, this was a very limited 4-season study that they did, and per season they collected about 10 samples, and they spatially varied them properly. And this is one of the good studies we have for Delhi, because they didn't just take the measurements and do some ions and metals. They actually looked at carbon profiles on the samples collected. So that's 2-3 times higher than what we usually do, both in terms of expense and also in the methodology. But it gives you a really good statistical fit when you start matching the sources. Okay, so between summer and winter, so it gives you a completely different picture. What are the sources that are contributing to my pollution in the summer versus winter? Very quickly, you can immediately see.
Yeah. Just a quick thing. Are you saying, based on this, that over the last 12, 14 years or so, Delhi's remained as bad as it is now? Or has it gotten much worse?
It's actually gotten worse. But in the same range. The numbers are in the same range.
I'm just looking at these numbers and looking at what you showed us earlier.
Yeah.
So, you think the support of the distribution is the same, but the distribution has moved a bit more to the
So the absolute number seems to be in the same range, but your mix of pollution has definitely shifted over the years. Yeah. In what direction? For things like your, your, your diesel pollution, secondary pollution has actually gone down over the years because you moved away from your diesel content, sulfur content in diesel in 2002, 2003 is much, much worse than what we have now. So the secondary contributions have really changed. We have much stricter controls on NO2, especially from the vehicles. So that changed the picture. The secondary nitrate, the secondary ammonium, and secondary sulfate component. So that part really changed the picture over the years. Okay.
So yeah, I thought this was a seasonal difference, rather than a year-to-year change.
So over the year, so you won't.
Typical seasonal difference.
This is typical seasonal, at least for them.
But you're suggesting also over time there's been a reduction.
There's been a
in the
change.
longer term in reduction in diesel,
Yeah.
in particular.
Yeah. And then this is a quick look at the study published by CPCB in 2010. We couldn't use the PM 2.5 pi as it was, so we took the PM 10 pi, we reduced the number for how much of that dust would actually remain in PM 2.5 and came up with a new pi, and would look something like this. So this was, again, very, very limited samples. The methodology adopted in the earlier study versus this is very, very different, and results are a little bit varied between the two.
Is this summer or winter?
All combined. Okay. And this is the study published by IIT Kanpur in 2015 for samples collected in 2013. Again, they did a summer-winter differentiation, and of course, we see a big change from what we've seen in the older study versus now. Again, so dust prominently shows up, diesel and petrol, that prominently shows up. Again, the methodology was slightly different. At least in CPCB's work, they claimed that they would use the source profiles that they built for the Indian cities. So here, the source profiles used in this study were actually borrowed from US. So we.
They are not matching with your results, this one?
I mean, they aren't my results. I'm just looking at what was summarized in those results.
No, the one which was done at Georgia Tech and this were not matching.
In a range. They're in a range. So it's hard to match them point to point. That would be, I think, not advised.
They are similar.
Similar, in a range wise.
Particulate matter is also, concentration is also similar.
So in 2015, these measurements were much, much higher than what was reported in CPCB or even in the previous work. So even for summer, they had averages of 300 micrograms per meter cube. So in this work. So winter time was also about 300 micrograms per meter cube, average.
And all of these were top-down studies.
All top-down. These are all top-down.
When we see these differences over a period of time, we read them as due to methodological changes or like variations that we see as an issue.
So that is what we see because we're actually going back and reading the reports. But what you see in the newspapers is basically they'll say, this study says coal is your biggest problem, or diesel and petrol is the biggest problem. So they won't actually go back and look at the methods that they were applied in putting this together, right? So, yeah. So what we have done is basically consolidated, yeah.
The previous one, the most striking thing that I see is that industries is very small. Is it because industries have been put into like diesel, petrol or something of that sort? Is that
Possible. So this goes back to that point, like how you feed your profiles in that receptor modeling and trying to statistically match will define your output. So based on some of the bottom-up work that we've been doing, and looking at the results that are for the last 10 years, we came up with a top mark for each of the sectors. Like how much can we put each of these sectors are responsible for the pollution. Okay, So transport comes up to about 30%. So that's the hierarchical. Up to 30%, like biomass burning up to 20%. Again, these are annual averages on an annual basis. Both the studies that we're looking at from those last 3 studies and some of the bottom-up work that we've been doing for Delhi. Okay. And I want to point you to that power plants up to 5%. Can you hear? As soon as the peaks start, we like Badarpur, close it. Okay, so as if that's actually your biggest problem, and it's not. Okay, and I want to give a little bigger picture as well. Delhi's load demand for power is about 5,000 megawatts. Okay, Badarpur at max, at like full capacity, it makes 300 megawatts. Okay, it's old. You want to shut it down because it's old, then shut it down for good. Okay, but it really has a very, very small impact on your overall air quality that you see in Delhi. So outside the urban airshed is basically what we have defined as your urban airshed for Delhi. It's about 80 by 80 kilometers, and this is the boundary conditions that are affecting. So you do have, once you get out, you have Jhajjar, Hisar, all those big agglomerations, and they also have a lot of emissions there. In the north, you have Sonpat, Meerut, have a lot of emissions there, and you have like also all the small other cities as well, and you have a lot of regional impact that comes in. Okay, so you have a huge belt of power plants once you get into Punjab, and you want to have, when you have a lot of seasonal activity that are happening, dust comes in the summertime, you have these open fires happening in the winter time, so all that contributes. So on average, up to 30% of Delhi's air pollution is blamed on outside pollution.
How much of this is done by people and how much of it is by, let's say, desert sand?
So your desert sand would be in that outside urban airshed component.
And the soil and road dust
Is locally generated road resuspension, construction dust. So that's your local generation.
So the crop burning is in the bottom category.
Would be we usually put it under the bottom one, yeah.
So the biomass burning is
That biomass burning would be your space heating, all the biomass used for cooking purposes. It's all local biomass burning. Okay. So if we started focusing on episodes, then that outside contribution would be really high. So if I made this graph just for those 2 weeks, then we'll be looking at a very high number for outside contribution, and we do see that. So if in April with a big dust storm passing through, then you'll have 80% of that would be coming from outside and 20% would be local. But then your margin is also very high. You're looking at 800 micrograms per meter cube and not at 200 micrograms per meter cube.
You also mentioned like one of the activities would come under biomass burning, which is like for cooking purposes, these are like small scale activities, right?
Yeah.
So are there like major scale biomass activities which contribute? Because 20% seems like a large chunk of the entire.
In the numbers that we see, it's not. But
Like
yeah,
I hear about like fires in the landfills.
yeah,
So like that would.
open waste burning, yeah.
So I'm happy to have these conversations, but I also need you to keep track. We want to make sure we get through to the end of this. So we
Okay.
keep it to very clarificatory questions right now. I think we can get through this and come back to the. They're all good questions.
I'll come back to that. Yeah, just remind me. So the problem is not limited to Delhi only. I want to quickly finish up with a little bit of a pitch for our other work as well. And we want to not just talk about Delhi. And this problem persists in pretty much all the cities. You have the same set of sources wherever you go. It's just that the level of contributions from each of these sectors vary from city to city. And again, the monitoring problem is also very, very high. So only in Delhi you have 20 monitoring stations that are operational, and you get out of Delhi, it's really very, very minor. You go to Patna, you have one, and you go to Ahmedabad, you have one monitoring station. It's not statistically representative in any form. Okay, you look at Uttar Pradesh, 200 million people, and you have 9 continuous monitoring stations, and pretty much all of you look like statisticians, and you do the math whether you want to use that information or not. And we also have beggars can't be choosers, so we are using that information because that's the only station that's available, and putting data online. And not many people know that CPCB actually have a thumb rule that they published in 2003, saying if this is the level of population in your district, how many monitors do you need to spatially and temporarily represent the pollution that you're seeing in the city? Okay, and they have this thumb rule very specifically: 1 for PM, 1 for SO2, 1 for NOx. So they actually have that, but it's not really followed. So what we have done is for every district we try to put together a number, saying if we actually followed that thumb rule, like how many monitors do we need in the country to be proud of that number. Like we were saying 150, then we know that statistically I can prove that it's 150. Okay. So we need about 4,000 monitoring stations, continuous monitoring stations, about 2,800 in the urban areas, 1,200 in the rural areas. And for Delhi, if you want a truly representative sample, you need about 77, and we are operational about 20. Okay. And the cities work that we have, what we call as SIMAIR, Simple Interactive Models for Better Air Quality. It's just a framework, it's a family of tools that we have in play, where we are digitizing and putting together databases for emissions. They run through the dispersion model to understand the concentrations and source contributions, and then you have the policy dialogue on impacts and what if scenarios, and then we basically go through the circle. We've been doing in piecemeal for a few cities in the past, and so in 2016, 2017, we put together stories for 20 cities. So those are the leaflets which are outside. A lot of information, a lot more information is there online. If you go to the website, we gave it a little punchy name for the program for Indian cities called APNA. It's Air Pollution Knowledge Assessment for Indian cities. And next year, we're going to add 30 more to that pool. 50 is a magic number. It actually comes out of the census. In census, we have 51 cities with 1 million plus population. So we are basically trying to get a story going for each of the cities. So a lot more is online, so please go take a look. And same databases are actually going into what we have as a short-term forecasting as well. So long-term is what if scenarios and looking at on annual basis how much is the pollution, but we are also interested in a short-term health alert system that can go out every day. So we have that also operational. So for every district at 9 p.m. there's a report for the next 3 days. How much is the pollution going to be in your district for the next 3 days? And since we have a very detailed inventory and modeling that's happening, we can also tell you if tomorrow is 100 micrograms per meter cube, how much of that 100 is coming from open fires or dust storm or vehicles or freight movement and local passenger vehicles, cooking, heating, spacing. We try to break it up as much as possible. Just a quick summary of just 4 cities. So Bhubaneswar's pie, annual pie, would look something like this. Chennai's pie would look something like this. And it's very interesting, but that waste actually shows up really significantly there. Industry is 13% because they have 2 large power plants, and they have a couple of refineries and a large manufacturing sector, all within the urban airshed. So it makes a huge difference. And more importantly, there's a big port. Okay, and a lot of freight goes in and out, and that basically 2 ports. Okay, so and that basically contributes a lot of contribution to the transport sector and the dust that's generated because of the movement in the city. So you go to another coastal place, Kochi. It's actually a lot more cleaner than compared to Chennai, but activity-wise, it is very high. But sea salt, the west coast sea salt is a lot higher than the east coast, and it's on an annual basis. It's actually true. And other one is Pune. Again, same thing. It's a lot of industrial activity is actually wedged between Pune and Mumbai. It's just outside the urban airshed, so you end up seeing a lot more contribution from that. What we are seeing as outside contribution, and within the city, it's a very active university town with a lot of IT industry. So you have a lot of passenger movement in the city. So if we actually break up the transport story between Chennai and Pune, you will actually see a lot more passenger related cars, motorcycles related emissions in Pune, and in Chennai case it will be a lot more coming from freight. Okay. So again, so we have a lot more stories that built in. So please go visit the site, and you'll have a lot more details of this. So what? So last few slides. A 5-point agenda is what we propose for most of these cities. Okay, in the sense having a long-term vision. Okay, clean fuel for all vehicles in all India. And this is something that we pushed even in 2013, 2014, like one nation, one fuel, because at that point we had Bharat 3 and Bharat 4 both in the running. And then we said, okay, all Bharat 4. And then now we said 2018 April, we'll get Bharat 6 for Delhi only. I think it's actually it's a losing cause, mainly because when you have so much freight passing through Delhi and all these trucks, they're going to be filling outside and they will pass through. That's your biggest problem, especially in the transport sector. They're still using Bharat 4, and you have a very, very active and young passenger fleet in the city. It's a rich city. On average age of car in Delhi is under 4 years. Average. Motorcycle is about 6 years. So which means that every 3 years your fleet is actually getting overhauled. Okay. And you do have benefits. Moving to Bharat 6, you definitely have benefits, and we will see that benefit in the transport portion of the pie. And but the only thing is, it will be short-lived. I mean, we will see a sudden drop in the contributions from transport sector in April, May, but then they will start ramping up with your vehicle numbers going up and your passenger vehicles going up, the passenger movement going up, and then more of the outside stuff coming in. So in general, what you want is a proper urban planning. If you have to aggressively push for promoting walking, cycling, public transportation, and para-transportation in the city, so that you basically consolidate the movement in the city. Okay, so especially looking at transport sector, you have to keep in mind transport emissions are defined by 3 parameters: your number of vehicles, vehicle kilometers traveled, and emission factor. Putting in a new emission standard for fuel will affect your emission factor. Okay, but if your number of vehicles and the vehicle kilometers traveled are always increasing, whatever benefits you get will be nullified in no time. Okay, so you have to have a proper urban plan in place, especially for the transport sector, so you gain the benefits from the emission factor, reducing the emission factor, but you also start reducing the number of vehicles there and number of vehicles traveled. When we can't stop people from buying vehicles, so your only other option is basically movement of the vehicles. So how much of those vehicles are being used? We have to start focusing on that. Just imagine if when you have this odd even scheme that we have put in place, but if we had a program in place where people are actually not using their cars, but they're actually walking and cycling. I mean, it's a what-if scenario. The benefits will be phenomenal. Okay. So you have zero emissions walking and cycling, and you have emissions from pretty much everything else. So a transport planner from Vancouver, he keeps putting out some of these things. I really like it. So, and the freight movement itself, I think there is a lot of changes that are happening in the freight movement, moving freight on rail. So, for example, this is actually at Goa, and on the west coast, a lot of freight actually is moved on the train. So on paper, it looks like it's moving in the trucks on the road, but they're not. The trucks actually get on in Kochi onto the train. The trains go all the way up to Baroda, and then they get off from there and they get into the northern belt. Okay, so and they're actually now building a similar network on the east coast as well. So it's going to change a little bit. And biggest, again, a lot of freight that we are seeing is actually coal, and how it's moved across the country. And this is something that we really take it very seriously. I mean, when you're building these emission loads, so it's one thing that we say, okay, I have 100 million vehicles, they translate to so much emissions, and where do I put those emissions? And it makes a huge difference where you put those emissions when you're modeling it. Okay, so a lot of physical surveys have to go in, and trying to understand how the freight is actually moved is also very important. Okay. And if you go to, for example, to the north in the Rohtang Pass area, only for 3 months, but the emission load here is much, much higher at the altitudes of 4,000 meters. So these trucks are fully loaded, first gear, moving at 4,000 meters. Okay. So if we apply emission factor measured in Pune at ARAI labs to a truck passing in Rohtang Pass, you're off. Okay. So you will say that the concentrations are 10, but you go there and measure, there will be 100, 200 micrograms per meter cube, primarily coming from. Okay. And of that 5-point agenda again, so power plants, industries, not just power plants, all the industries, we need to have a program to enforce the laws that we are passing. So right now, that's very, very weak. We have laws. Okay, we have laws for everything. When we banned waste burning very long time ago. So you go, we hear a speech from any other pollution control, but people, they will say it. We ban waste burning, but it happens. Okay, so the enforcement part has to really kick in at some point, and it has to go in. So I think one sector where we are seeing a lot of positive action is in the household sector. And a lot of LPG connections are going up, and the Ujjwala program and everything else. But there is also other surveys that are being done, how often they're being getting a new cylinder, are they keeping up with the buying part and things like that. But at least there is a positive story that's spinning along those lines. So again, waste management, this is one thing that's really, really poorly maintained pretty much in all the cities. Okay, so this is Mumbai, the Chembur landfill. It burnt twice, once in January and once in March. And it was large enough to actually seen in the satellites. Okay, most often we don't see the small garbage burnings that happen, but this was large enough that we actually saw it. And since we are talking about, we're in the zone and open fires, so very little is being done in this field at the moment. And one, there are a lot of factors. How do we convince farmers from not burning, and what alternatives do we are there, or what alternatives are we providing? So as researchers and scientists, we can only put these things on paper, and they all look good, but in practice, it's a completely different story. And I think that's where a lot of push has to go in. I mean, we have a lot of pilots. Now you collect all the agro waste, and we can make briquettes, and we can use them for burning through the winter season. It actually sounds very good. Okay, so you don't burn it over there, but you're actually supplying some kind of compressed material for these guys to burn, so that it's actually a little bit better than what they're using now. So those kind of possibilities exist. Same thing happens for the brick kilns as well. So brick kilns, they actually take up whatever is cut from these fields. What they don't take is whatever is left on the field, which gets burnt. So a combination of all these things is possible. So how do we put that into practice is something we need to talk about. Again, firecrackers is something that we talked about earlier. I mean, we have a law, but people are going to buy and burn them anyway, then it becomes a waste. So a lot of public awareness has to go in. This is almost, yeah. And we also hear a lot about, we'll put vacuum cleaners at the traffic intersections, or we use helicopters to sprinkle water on the roads. It doesn't work. No, you really have to tackle the problem at the source, and not where you're breathing, not where you're standing, not where you're playing. The solutions have to come at the source. Okay, and I'll stop with this. The point I want to make is we shouldn't be focusing on the episodes themselves only. We have to have a long-term vision, so that we have a collective story and a story that includes all the sources which are there all year long. And then then that you have a strong view and a strong strategy in place that helps everybody. Okay, thank you.